Okay, so recording homework review on Tuesday, November 17th. We're getting ready for the test in unit number 3, which covers sections 3, 4, 3, 5, 4, 1, and 4, 2. Not 4, 3, not 4, 4, so be mindful about that. So here's homework number 19, which had some focus on the chain rule, and then the rest were all on implicit differentiation. Someone asked about number 56F. So for 56F, here's what we do. We're going to say y equals root f of x, which is no different than saying f of x raised to the high power. We know this, right? So now you do a derivative. That's going to involve the chain rule. Do the 1/2 to the front, drop the exponent by 1, and multiply by derivative inside, which of course the inside is f of x, right? That's my inside. So I'm going to do f prime of x. Okay, so we're halfway there. Now we have to do is plug in 2 for x. I'll do that right now. Y prime is 1 over 2 root f of x times f prime of x. Just cleaning up a little bit, and then I'm going to plug, actually, let's plug in 2 right now. Okay. Well, f of 2 is easy. That's just 8, right? Probably off to the side, we probably should just extract that information, right? And f prime of 2 is 1/3. Throw it in, and you're done. There you go. So y prime will be 1 over 2 root 8 times 1/3. And you know what? Leave your answer like that. That's fine. That's totally okay. They do simplify it. I mean, a little bit, like root 8 is 2 root 2. And that's just the textbook getting kind of cute there on us, but I don't care. Actually, what I'm probably going to wind up doing anyway is making this a multiple choice problem. And then you just have to match with one of the choices. And I'll probably choose numbers that are somewhat reasonable. They're not too crazy with the simplification, because I don't want you guys to kind of get stuck on that. So I'll be very mindful of how I create my answers. I'll make sure reverse engineering things work out nicely. But I do want to see that skill, right? You know, like, yeah, can you do that? So that's 56F. Any questions about 56F or anything else from 56 on this page here? Nope, we're okay. Very good. Okay, well, let's keep moving. The next question was on number 13. 13 is a good one. Actually, I like this problem a lot. This is a great problem because we had this in our notes. In fact, if I pull up the lecture notes, that was, I think, in example 5 of the 4.2 notes. So page 4. Yep, example 5. Here's what you're asked to find where it's defined. Really, a better question is where is it undefined, right? So that is our equation. You know what I'm going to do right off the bat? Let's just throw this into Desmos, just so we know what the answer should be. Really easy to do. X squared y minus xy squared. Okay, I think I could remember that. X squared y minus xy squared. So go to Desmos. What was it again? Okay, my short-term memory is terrible now. X squared y. I thought it was xy squared. See, x squared y. Okay. X squared y minus xy squared equals what? So again, my short-term memory is terrible. 4. Okay. 4. So where's going to be undefined? Probably somewhere over here, because you'll probably have a vertical tangent, right? I don't think you're going to see any vertical tangents here. You're going to have a vertical asymptote for sure at x equals 0. So I suppose you could say that where it's not defined, because it's going to be a discontinuity. But also we have vertical tangents, which is probably going to be somewhere over here. So we'll need to figure that out. So let's go back to the problem and work it out and make sure we get that. Okay, so I need to take the derivative. So that's going to be, you might want to do this, x squared y prime and xy squared prime. So you take rid of x squared, which is 2xy, plus x squared times dy dx. Easy peasy, right? Here, take rid of x, was 1 times y squared, plus x times 2y times dy dx. Again, easy peasy, right? Not too hard. So you bring it back into the fold. So you got 2xy plus x squared times dy over dx, and then big minus, and then in parentheses, y squared plus 2xy times dy over dx. And that's going to equal 0. Then you isolate dy over dx. In order to isolate correctly, strongly recommend you distribute that minus sign, right? And isolate the dy over dx. We have dy over dx happening in 2 locations, here and there. So the ones that are not dy over dx, move that to the right side. So let's do that right now. I'm going to pull out dy over dx from the 2 terms I kept on the left side. So x squared minus 2xy. The other terms that didn't have dy over dx, move it over. So it's y squared minus 2xy. And then you divide by x squared minus 2xy. Now my answer looks a tad different than what you see in the solution case, and that's okay, because I just reversed it. I think they may have moved the dy over dx from left to right, and then I said dy over dx. It's the same thing. It's just that our numerators and denominators are just reversed. It's the same thing. It's like multiplying top and bottom here by -1, and then you get the same thing I got there. So that's half the value. The other half is fine where it's not defined. So what you'll need to do, I'll do this in red. I'll do it off to the left again. So let me erase all this junk. We don't need any more. Erase. Okay. So you set the bottom equal to 0, factor on x. So course x equals 0. Or x minus 2y equals 0. Meaning that x equals 2y. Or y equals half x. Definitely, for sure, it's undefined that we saw there was a vertical asymptote or discontinuity. This would also be a problem too. And if you want to find a specific point, I actually probably would keep it as x equals 2y and substitute that in. So it'd be 2y squared times y minus 2y times y squared equals 4. That's 4y cubed minus 2y cubed equals 4, meaning that 2y cubed equals 4. Y cubed equals 2. Y equals a cube root of 2. And then you can throw it back in to get the x value, which would be double that. 2 times the cube root of 2. And I got my trusty calculator to kind of see what that is as a decimal. 2 times 2 raised to the 1/3 power. It's about 2.5198. And if I actually go to back to Desmos again, yeah, it looks like you do get a, let me clear my screen. Looks like we would get a vertical tangent around there. So that makes sense. So I feel good about that. Okay. So that's 13. And then finally for, okay. I will just tell you guys right now, you're not going to see a problem quite like 56. It's a little much. The concepts are good. I think just the combination of all of it of one problem is just a little too much, and you may not. You wouldn't have time for the stuff in the test. So I'm not going to ask one quite like that, but I'm going to do this problem anyway because it is good practice. So here's you're asked the line that is normal to this curve at 1, 1 intersects a curve. What other point? So here's what's going to happen. Let's actually draw this in Desmos again. So x squared plus 2xy minus 3y squared. Plus 2x minus 3y squared equals 0. Plus 2xy. That's weird. Did I type that incorrectly? I suppose so. Okay. What 1, 1? That's really strange. Okay. All right. So be it. So there's 1, 1. So you have a tangent line. So it looks like a normal line will be just kind of straight, but a tangent line will be coinciding with the curve itself. Your tangent line will probably do something kind of like this. Sorry, normal line will do something kind of like that. And so you're trying to find where else it intersects. 21 and 23. I suppose we could do it if we have time. Let's take a look. I won't do both, but I'll do 23. Then maybe I'll have you try 21 on your own. But let's finish this problem up first. So what you're going to need to do is first find your derivative, which is really easy. 2x plus 2 parentheses minus 6y times dy over dx equals 0. Now, so the inside. So you're going to do derivative of xy. We know that's 1 times y plus x times dy over dx. And what I'm going to do is I'm just going to plug 1, 1 in right now for x and y. And just let's just get what dy over dx equals. So that's something you could do. Instead of isolating dy over dx algebraically, we just need to get the slope, right? Because remember, the derivative is the slope of the tangent line. And then we get the slope, remember, dy over dx at 1, 1 will be the slope of the tangent line at 1, 1. Then we'll do a negative reciprocal for the normal line. But let's work this out. 2 plus 2 times 1 plus dy over dx minus 6 times dy over dx. So it's 2 plus 2 plus 2 times dy over dx minus 6 times dy over dx. Oh, goodness. A lot going on here. So you have 4 on this side, move that over to the other side, you get negative 4. 2 minus 6 is negative 4 also. So dy over dx equals 1. So my normal line will have a slope of negative 1. The perpendicular slope is going to be negative 1. So what this means is that my equation of my normal line, I'll do this in green, the equation of my normal line will be y minus 1 equals negative 1 times x minus 1. Or y minus 1 equals negative x plus 1. Or y equals negative x plus 2. Now, that's the normal line, negative x plus 2, which actually looked like this we got in Desmos, right? It looks like we did have that. Negative x plus 2 kind of makes sense. So where else does it touch it? Well, obviously right here. How do you find that other point of intersection? Substitution. That's algebra. This is the algebra that goes on here. So you substitute y equals negative x plus 2 into this equation. I'll do that in blue. So x squared, you can see why I don't want to ask this because it's a little too much. Then you have to work that out. That's x squared minus 2x squared plus 4x plus 3x. No, I got to see, you can see why I'm a little frustrated here. You have to FOIL that, which is x squared minus 4x plus 4. So I did that in my head. Then you guys do -3, then you got to combine like terms, then you got to solve it. You will get 1 and 3 as your answers. So you get x equals 3, and then you get the y value, which is going to be at -1. Just trust me, that's what happens when we work it out. But in the interest of time, I'm not going to do it all completely because I want you guys to go to a breakout session very soon. So I won't do a whole thing completely, but just trust that's what happens. But I just think that's a little much for a test problem. I think it's just, and plus just to try to even process what you got to do. It's easy for me to process because I teach this stuff, but you guys are students, right? So I have to recognize that this would take you too long to process. So I'm not asking like this, but it's a good question because, yeah, you got to find a derivative. You got to know the derivative of the slope of the tangent line. Then the normal is a negative reciprocal. I know that, and how to write the equation of a normal line. I think those are all fair things to ask. But then when they take a step further, say, oh, where else does that normal line intersect the curve? That's just an algebra problem. That's substitution, and we've assessed that skill in you guys over the years, so I don't need to assess it again. So we'll move on. 23. I won't do 20. I'll do 23, and then we'll go to a breakout session in about 3 or 4 minutes from now. So for 23, again, let's take the derivative. So 2, that's going to be y plus x times dy over dx. We already know that derivative x, y, that involves a product rule, but it's implicit, so you got to make sure you take care of that. Plus pi times cosine y. And remember, your inside is y here, and you're going to do with respect to x, right? We're doing both sides with respect to x. So I got to say times dy over dx equals 2 pi. Now, just to save time, let's just plug 1 and pi over 2 right away. So you have 2 times pi over 2 plus 1 times dy over dx plus pi times cosine pi over 2 times dy over dx. And I messed up. The right side is not 2 pi, it's 0. We know this. The derivative of any constant is 0. My bad. Equals 0. Now you got to solve for dy over dx. Your job is to solve or isolate all that, which I know you guys can do. But what do? Well, let's distribute. So 2 times pi over 2 plus 2 times dy over dx plus pi. Cosine pi over 2 is 0, right? We should know that from unit circle, or you could use a calculator. That goes away. So now you just got pi plus 2 times dy over dx plus 0 all equals 0. Isolate, and you should get negative pi over 2 as your slope. That's slope of the tangent line, and then your equation of the tangent line is y minus pi over 2 equals negative pi over 2 times x minus 1. Now the question, the textbook, they put the answers in point slope form. I want you to leave it in slope intercept form. So they put the answer in slope intercept form. I want the answer in point slope form. So leave it in point slope form, and you're okay. That's totally okay. And then the normal line is easy. Just do the negative reciprocal of your slope, 2 over pi times x minus 1. And there you go. If you want to rearrange it to match with the choice they have in the textbook, knock yourself out, but you're fine here. And by the way, you could plug this in your calculator and plug in the normal line, and they should link up correctly at 1 comma pi over 2. So I'll do that really fast so you can see that in action one more time. So 2xy plus pi sine y. You just type pi for sine. And I type in my tangent line. clear my screen, zoom in, and that looks like a tangent line to me, and it's hitting it. The nice thing about Desmos, it gives you points of intersection really easily at 1, 1.5, 1.571. Well, pi is 3.14, pi over 2 is 1.57, right? So I know I've done this correctly. I feel good about this now. So that's how you can verify your work. Okay. So I think I spent a little bit more than I had hoped on the homework review. If you have other questions, call me in the breakout room. Like, hey, Mr. E, I really had a hard time with this homework problem. Just call me over. I'll come help you out. I'm actually going to check on you guys as well, just make sure everything's going okay. So we'll do a breakout room for, I say, let's do 25 minutes. I think that's appropriate for the board problems. So the board problems, here's what I want you guys to do. I'll put you guys in groups with maybe 3 or 4 people. Actually, no, we'll do exactly 4 people because we have 20 people in this class. So you can see in the file name itself, I say ignore number 3, 4, and 8. That's because 3, 4, and 8 cover topics we've not done yet. Number 3 talks about derivatives of exponential and logarithmic functions. Sorry, exponential functions. We have not done that yet. Yeah, you could do part C, but those ones are a little hard to do. 4 is inverse function. We've not done derivative inverse functions yet. We'll do that after Thanksgiving break. And 8 involves an inverse trig function with an exponential function. We have not done that yet either. However, 1 and 2 are linear motion, and that might be a good review. Number 1 gives you a position graph. Number 2 gives you a velocity graph. So you have to interpret them differently. Remember, your rest when your velocity is 0. You're moving to the right when your velocity is positive. Your particle changes direction when the velocity changes sign. But you have to look at it a little differently when you're given a velocity graph. Remember, you're speeding up when velocity and acceleration are the same sign, both positive, both negative. You have positive acceleration when the derivative of velocity is positive. We know this, right? 5 and 6 are fair problems. 5 is chain rule. 6 is product rule with the trig derivatives. 7 is implicit. And find the equation normal line to the curve. And 9 is more implicit and is the second derivative. And don't worry about how much you simplify number 9. As long as you kind of get somewhere in the midway of the solution, that's fine. The solutions are in Schoology as well, so you can check your work. So you guys will be working on 6 problems: 1, 2, 5, 6, 7, 9. So we'll give you guys 25 minutes to do that. We'll come back from the breakout session at around 10:20-ish, at 10:22. We'll see if there are any questions. And we go to 11:40 today. So maybe I'll have you guys go to one more breakout session after that. Or maybe we'll just do one problem from the test. Maybe I'll just do it with you guys. And then we'll be done for the class today. Okay. So let me stop sharing. Let me stop the recording.